Is there a place in the universe where time literally moves slower than anywhere else we know? I'm not talking about that feeling you get when an afternoon drags on. I mean a real, measurable, physical phenomenon that challenges our most basic understanding of reality. To get our heads around this extraordinary place, we first have to accept a strange truth. Time isn't a universal constant. It doesn't tick at the same rate for everyone, everywhere. Einstein told us this over a century ago with his theory of general relativity. He taught us that gravity isn't just a force pulling objects together. It's the curvature of the very fabric of space-time. The stronger the gravity, the more space-time is warped, and the more time itself slows down, like thick honey. So, if we want to find the place where time slows to a crawl, we need to find the place where gravity is at its most extreme. And for that, we need to look for the densest, most massive, and most terrifying objects in the cosmos. Supermassive black holes. These are cosmic monsters, millions or even billions of times the mass of our sun, all crushed into a point of unimaginable density. There's one lurking at the heart of nearly every galaxy, including our own Milky Way. And around these gravitational titans, time behaves in ways that seem torn straight from a science fiction nightmare. The event horizon of a black hole is famous. It's the point of no return. The boundary where not even light can escape the crushing pull of gravity. But just before you reach that boundary, there's a region where the effects of time dilation become truly extreme. Imagine you're in a spaceship, orbiting very close to a supermassive black hole. From your perspective, everything would seem completely normal. Your watch would tick at 1 second per second. Your heart would beat at its usual rhythm, and your thoughts would flow, just as they always have. But for someone watching you from a safe distance, far away in a region with normal gravity, it would be a completely different story. To them, you would appear to be moving in extreme slow motion. Your every gesture would take hours to complete. Your words would stretch out into a deep, endless drone. If you were to spend just a few minutes in your time orbiting that black hole, decades, centuries, or even millennia could flash by for the rest of the universe. It's like the twin paradox, but taken to its absolute cosmic extreme. This is nature's own time machine, built not with impossible technology, but with the fundamental laws of physics. So, where is the specific place where this effect reaches its known maximum? It rests right at the edge of the event horizon of the largest supermassive black holes who've discovered. Objects like Ton 618, a beast with a mass of 66 billion times that of our sun, or Phoenix A, which is even larger. Near these cosmic behemoths, time doesn't just move slower. For an outside observer, it would seem to practically stop. So how does this actually work? How can gravity literally slow down time? To understand this, we need to dive into the concept of Imagine the universe is like a giant stretchy sheet of fabric. This is our four-dimensional Now, anything with mass, like a planet or a star, creates a dent in this fabric. The Earth makes a small dip. The Sun creates a much bigger one. But a supermassive black hole, it creates a gravitational well so deep it's practically bottomless. When you're moving through this curved space-time, you're not just traveling through space, you're also traveling through time. The deeper the curve, the more your path through time gets bent. It's almost like time and space start to trade places. Close to a black hole's event horizon, what used to be a direction in space-like, forward becomes a direction in time. It becomes the future. This leads to some truly mind-bending situations. If you were watching someone fall towards a black hole from a safe distance, you'd never actually see them cross the event horizon. As they got closer, you'd see them slow down more and more, until their movements became impossibly slow. The light from them would stretch out, shifting towards red, until they just faded away. From your perspective, they'd be frozen at the edge forever, like a ghost in a photograph. But for the person falling in, it's a completely different story. They wouldn't feel anything special as they crossed that boundary. They would just keep falling, unaware that they've passed the point of no return. Only later would they realize there's no way back out. It's two completely different realities, both equally true, just depending on where you're watching from. Scientists have done the math. For a supermassive black hole like Sagittarius A*, the one at the center of our own Milky Way, time near its event horizon runs at about half the speed it does here on Earth. For even bigger black holes, this time, dilation effect is even more extreme. Then there's the photon sphere, a region just outside the event horizon where gravity is so strong that even light can get trapped in orbit. Here, the curvature of space-time forces light rays to travel in circles. If you were in the photon sphere, you could theoretically see the back of your own head, as the light from it would circle the black hole and come right back to your eyes. But maybe the strangest part of all is what happens once you're inside the event horizon. The singularity, that infinitely dense point at the center of the black hole, isn't a place in space anymore. It's a moment in time. It's your inevitable future. No matter which direction you try to go, every path leads to the singularity. Just like how for us, every path leads into the next second. Space-time is so warped that the future has become a physical place. And that place is the end. This means once you're inside, you can't avoid the singularity any more than you can avoid tomorrow. It's a fundamental law of physics inside that boundary. And as you fall toward this inescapable fate, time for the rest of the universe would speed up wildly. From your point of view, you'd see stars born and die in the blink of an eye. You'd watch galaxies collide and the entire universe age before your eyes, right up until the final moment before you simply cease to exist. So what does all this mean for us? These tiny creatures orbiting a common star in a spiral arm of a galaxy among trillions. It means the universe is much stranger, much more complex, and frankly, much more frightening than our intuition can ever comprehend. It means that time, this thing that seems so solid, so reliable, so absolute, is actually malleable, relative, and deeply connected to the structure of space and gravity. Supermassive black holes aren't just fascinating astronomical objects. They are natural laboratories where the laws of physics are pushed to their absolute limits. They are places where our very notions of past, present, and future become confused and intertwined. They are the places where time literally moves slower than anywhere else in the known universe. And perhaps, most disturbing of all, these places truly exist. They're not just thought experiments or theoretical concepts. They are out there in the cosmos, curving space-time around them, creating these bubbles where time almost freezes relative to the rest of the universe. And one of them is right at the center of our own galaxy, just 26,000 light-years away. Of course, even at the speed of light, it would take us millennia to get there. And if we got too close, gravitational tidal effects would tear us apart long before we could experience the most extreme effects of time dilation. There's a technical term for this: spaghettification. The difference in gravitational force between your head and your feet would become so great that you would literally be stretched like spaghetti until your atoms were torn from each other. But in a sufficiently large, supermassive black hole, you could cross the event horizon without being immediately destroyed. You would have a few moments, maybe even a few minutes, to contemplate the impossible. To look around and see the entire universe accelerating around you, aging before your very eyes, as you fall toward the singularity, toward the point where all the laws of physics we know simply stop working. And then, in that final instant, when you finally reach that point of infinite density, what would happen? Nobody knows. Physics breaks down. The equations return infinities. Perhaps time simply ends. Perhaps you're crushed into a dimensionless point. Or perhaps, just perhaps, something completely unexpected happens. Something our current science can't even begin to imagine. The place where time moves slower than anywhere else is not just a physical destination. It's a concept that challenges everything we thought we knew about reality. It is a reminder that we live in a universe far stranger and more wonderful than we could have ever dreamed. And it's a window into the deepest mysteries of existence. If you've made it this far, congratulations. You've just taken a mental journey to the most extreme confines of known physics. And if this content expanded your mind, if it made you question the nature of reality, then leave a like now. Share this video with someone who needs to have their mind blown. And in the comments, tell me, would you have the courage to approach a black hole, knowing you could never return? That, for you, time would effectively stop, relative to the rest of the universe. And of course, subscribe to the channel and turn on notifications. Because in the next video, we're going to explore another disturbing cosmic mystery. A phenomenon so strange it might just prove we're living in a simulation. You won't want to miss it.